Lastly, in our series of antiderivatives of non-power functions, we're just going to look at these simple rules of reverse and inverse trigonometric function. Recall that the derivative of sine inverse is 1 over the square root of 1 minus x squared. So it only makes sense that the antiderivative of 1 over the square root of 1 minus x squared is sine inverse of x plus c. Or you could say arc sine, depending on how you want to call it. The rest of these rules just work exactly the same way. So 22, antiderivative of negative 1 over square root of 1 minus x squared is equal to cosine inverse plus c. Next rule we have integral of, or antiderivative of 1 over 1 plus x squared dx is equal to tan inverse of plus c. And then lastly, the last three rules, antiderivative of negative 1 over 1 plus x squared is equal to cotangent of inverse plus c. Next rule we have antiderivative of negative 1 over absolute value of x times the square root of x squared minus 1 dx is equal to cosecant inverse of x. You know, these are very particular rules. I mean, and that's one of the reasons I'm not going to do an actual full-on example with these, because they're so complicated. They only really work if the form is exactly how it should be. You know, if one thing is off, like if I added another x, for example, it wouldn't work. You know, the only other application would really be if you had like a 2 here, you could pull it out, and then just the answer would be 2 cosecant inverse of x. And then lastly, we have rule number 26, antiderivative of 1 over absolute value of x times the square root of x squared minus 1. Difference between these two is there's no negative. That equals secant inverse of x plus c, or again, you could just say arc secant. And that's the last rule we're going to look at for now for antiderivative of non-power functions. If you have any other questions about this or any other antiderivative rule, let me know.